Hi, welcome back, period 6. Raymond, you can put that away if you like, as long as you hook it up properly. You can get out of your seat and do things because you're on the other side of the camera. It's fine, it's not a problem. Even if you want to be in the video, you can do that too, okay? All right, now, so I have two vectors, A and B. Vector A, 45 degrees to the horizontal, and it's going to be 100 newtons. B, it's going to be 50 newtons at 30 degrees. Clear? I want to resolve those two vectors. Now, the first part in resolving the vectors will be doing this, using these two equations to come up with the values here. It's actually a technique, really. There's very little thinking involved. The thinking comes in here. That's the thinking section. Okay? So let's do it right away. So 45, so 100 cosine 45 is what? 70.7. Excellent. 70.7, and it will be the same for both, correct? All right, now, very important. What's going to be the sign of each one?
Positive.
Positive. Why?
Because it's in the first quadrant.
It's in the first quadrant. Positive, positive. Excellent. Cameraman got it right. Now, what is going to be 50 cosine 30? 50 cosine 30? 43.3. 43.3 echoes here.
With negative signs.
Negative signs. Excelente. 43.3. And what's this one over here?
Negative.
What is it? All right, just give me the magnitude. 25?
Yeah.
All right, now, then you go in and put in negative. And the reason we do that is because, you know, we don't use, if you use like the total angle, like 100, 210 degrees, it would come out negative. But I don't want to worry about that. I want to keep this basic. I don't want to use that much of trigonometry. Just very, very basic relative to the nearest horizontal. Clear? Okay, now. So, 70.7 minus 43.3. What is it? The bells, the bells, the bells. There must be a poem. What is it? 27.4. 27.4, but what is that?
Positive.
27.4 positive. Clear?
Clear.
27.4, 27.4, and that's going to be positive. Okay, you got it? Is that easy?
Yeah.
Okay, good. Now, let's make that a little bit nicer. Okay, now, what is 70.7, a positive 70.7, and a negative 25? 45.7. They're on the ball. So say that again.
45.7.
45.7, and that's going to be negative or positive?
Positive.
Positive. Excellent. So now, what is going to be the quadrant that the answer is in? The first quadrant. Excellent. So that'll be number 1 quadrant. How do you know that?
Because they're both positive.
Because it's positive, positive, so it's going to be in the first quadrant, correct?
Yeah.
Now, using these two equations here, I'm going to get the magnitude and the direction. What is the square root of x squared plus y squared?
53.3.
Do we have a verification on that? Please verify that. Square root, parentheses, 27.4 squared plus 45.7 squared in parentheses. What do you got?
Yeah, what do you got?
Well, could you repeat it, please?
Yeah, hold on, wait. I just erased it. Oh my god. Katie got it.
Could you say that?
53.2.
53.2. Excellent. 53.2. What? 53.2 newtons, right?
Yeah.
You guys can go if you want. You don't have to stay. 53.2 newtons, correct?
Yeah.
Okay, now, what would the direction be? Look at the direction. How would I do the direction?
Arctangent.
Arctangent, 45.7 over 27.4. Because we're doing it this way, you don't need the signs, right? Yes? I'll show you why in a minute, but go ahead.
I got 59.1.
59.1. Do we have any verification on that? 59.1. So arctangent 45.7, arctangent 45.7 divided by 27.4. We're getting a verification. 59.1? Okay, now, that's degrees, but we need something more than just 59.1 degrees. Remember, it's in the first quadrant, so it's going to be, what's the compass reading going to be?
Northeast.
North of east. Excellent. North of east. North of east. Excellent. Now, what about the equilibrant? What's the equilibrant going to be?
The opposite.
Yeah, so, you know what? Let's do this. Let's approximate this. This is going to have a magnitude of 53, which is about that long, according to our drawing that is not to scale, okay? So it's going to be in the first quadrant at 53, so it'll be kind of like this, won't it be? It'll be a little bit like that, correct? Does that make sense? Yes? So then this will go down like this. Okay? Right? Does that make sense, Master Manus? So what would the, well, that looks terrible, doesn't it? A little curved in there. Shall we redo that? Okay? You know what? Let me do this with a ruler.
There we go. That's better.
All right. So that looks good. Yes?
Yeah.
Not to scale. Just give you an idea. Give you an idea. So what is the equilibrant going to be then? What quadrant is the equilibrant going to be in?
Third.
Third. It's opposite, right? Opposite. Okay. What is going to be the magnitude?
53.2.
Yeah. Listen carefully. The equilibrant is equal and opposite. Okay. So 53.2 newtons. And what is the angle going to be?
59.1 south of west.
Excellent. 59.1 south
West.
of west. Is there anything I forgot? Can we draw in that equilibrant just a little bit better? Okay. All right, so this will be, that's approximately correct. That's approximately correct. This was 50 newtons?
Yep.
That's approximately correct. Do you understand? Do you get it? So let's just review very quickly. We have two vectors, okay? This is going to be the resultant here. That's going to be the resultant, that black line. This will be the equilibrant. And this is how we did it. Clear? Now, it should make intuitive sense to you. The answer is always going to be between the two vectors. That's going to be the resultant, right? So if I have a vector here and a vector here, it's going to be somewhere in here. And it makes sense that it would lean towards the 100 Newton one, right? That makes sense? Okay. And then the equilibrant is the one that is opposite the resultant. Remember the force board experiment? You had to come up with the resultant. Clear? Any questions? How was that? Was that good?
Yeah.
All right. Hit it.